Okay, section 11.4 is the last video in chapter 11 on hypothesis tests. And this is going to feel a little bit like the section 11.31, kind of less calculation intensive than the kind of heavy computative stuff in sections 11.1 and 11.2. And really this whole section focuses in on something called a type 1 error and a type 2 error. Oh, that's the wrong thing I wanted to do. I wanted my pointer. There it is. Ignore this little mistake. See if I can erase it. Can I? Oh, I can't. Okay, there it is. So let's focus on, first of all, what's the definition of a type 1 error? By the way, let's focus on the word error. So these are cases where actually you did the hypothesis test, and even though you didn't do something wrong, you ended up making the wrong decision. And we'll talk about that a little bit. That's why we call them errors, because you ended up making the wrong decision. A type 1 error is where you reject the null hypothesis when you actually should not have, when the null hypothesis actually is true. Whereas the type 2 error is the opposite. It's where you fail to reject the null hypothesis when actually you should have rejected the null hypothesis. Let's look at a few examples, and a chart might help us. So this chart, let's make sure we understand what it's telling us. So up here, this is the truth about the population. The null hypothesis is true, or the alternative hypothesis is true. Over here, this is the decision you make. You either reject or fail to reject. And notice we're not using the word accept. Well, first of all, let's focus on this box, right? If an alternative hypothesis actually is true, and you reject the null hypothesis, you've made the correct decision, right? Way to go, you've made the correct decision. Similarly, over here, if the null hypothesis is true, and you fail to reject the null hypothesis, again, you've made the correct decision, right? These two smiley faces are not errors. The errors come in over here. So let's talk about this one. If the null hypothesis is true, but then you reject the null hypothesis, you've made what we're going to call a type 1 error. And then the opposite of that is if the null hypothesis was not true, the alternative hypothesis was true, but you failed to reject the null hypothesis, you made what's called a type 2 error. Okay? So it's a little bit of a tricky idea, but let's make sure you understand that identifying a type 1 error and a type 2 error. And let's look at a few specific examples. Okay, kind of think about a simple test for something like AIDS or some serious disease. The null hypothesis would be, again, usually kind of everything is normal, so okay, you don't have AIDS. The alternative hypothesis would be you do have AIDS. A type 1 error would be where you reject the null hypothesis where you should not. So that would be a false positive, where the test says you have AIDS, but actually you do not. Okay, and that would be a type 1 error. A type 2 error is the opposite. It's where you fail to reject the null hypothesis when you should. So that would be a false negative. The test would say you do not have AIDS, but actually you do. We'll talk a little bit about which one is worse, a type 1 error and a type 2 error. Clearly in this situation, a type 2 error is worse, I would think. I think pretty clearly it is. But I don't want you to think that in every situation a type 2 error is worse, although I think it's probably easier to think about situations where a type 2 error is worse. For example, the next one I think definitely falls in that category. Let's say you work for mission control at NASA, and it's your job to press a button. You work at this, they're launching some rocket, and it's your job to basically say everything's okay to go. That's the null hypothesis. Or we want to abort the launch because there's some sensor that says something's wrong. Okay, what would a type 1 error be? A type 1 error is where you reject the null hypothesis when actually you should not. So in that case, you would abort the launch when actually it turns out things actually were okay, and you could have gone ahead and launched it, and things would have been okay. A type 2 error is where you fail to reject where you should not. So the type 2 error in this case would be you failed to abort the launch, but actually things are not okay. So the rocket's probably going to blow up or something like that, or the satellite's going to blow up. Again, in this case, which is worse, I think pretty clearly a type 2 error is worse because you've lost your million or billion dollar system. So let's try to think of an example where actually a type 1 error might be considered to be worse. So imagine you've got a bunch of stock, and you're basically going to sell when you feel like the market is such that you're going to make a lot of money, or there's some fluctuation in the market. So the null hypothesis is there's no fluctuation, so you're going to just hold. Situation is normal. The alternative hypothesis is you've realized there's something true about the market and you're going to sell. So a type 1 error would be when you reject the null hypothesis when actually you should not. So you sell your stocks when actually you should not have. And the consequences there would probably be you would lose a lot of money. A type 2 error would be you fail to reject when you should have. So that would be you do not sell your stock when actually you should have, that's bad, but that's really just more of a lost opportunity, whereas a type 1 error is actually consequences you lost some money. So I wanted to show you this one because I think it's a little bit harder to think about, but there are many situations where a type 1 error people would consider to be worse. We'll talk a little bit about what's the probability of these things happening. So let's talk about, first of all, what's the probability of a type 1 error occurring? Well, that is actually alpha. And if you think about it for a second, I think that makes some sense. Alpha is our significance level. We usually talk about alpha being 5%. We've used that notation before. So so if you're going to say something unusual is going to cut off for unusual, something's going to happen 5% of the time. Well, 5% of the time it'll just happen by random chance, and we will call that significant. So, 5% is this threshold for something unusual happen. Something unusual is going to happen 5% of the time, and then we'll reject the null hypothesis when actually it just was due to random chance. So that's the probability of a type 1 error is always whatever you're calling alpha, usually 5%, although sometimes some other number like 1% or 10%. The probability of a type 2 error, we're just going to call that number beta. And it turns out we're not going to really ever calculate beta. Usually they'll give us that in the problem for some reason because the calculations get a little bit involved. There is an example in your textbook. But just think about it that beta is the probability of a type 2 error occurring. Really, that calculation you can't really do without knowing kind of more about the problem. And so we're not going to talk about it too much. But if you just remember that a probability of a type 1 error is alpha, which you know, the probability of a type 2 error is beta, which we can't calculate, but they'll just give it to us. Now that we have that notation, let's talk about a new term, which is something called power, the power of a test. And the power of a test is defined to be 1 minus the probability of a type 2 error. And so therefore, think about a probability of a type 2 error is beta, so the power of a test is just 1 minus beta. That's kind of a formula that you might kind of need to know. The power of a test is 1 minus beta, where beta is the probability of a type 2 error. When you think power, I think it's easier to think about just replacing the word powerful with the kind of word sensitive. The AIDS test, we would say, is a very powerful test. Powerful in the sense of being it's very sensitive. Since for the AIDS test, you really don't want to have any type 2 errors. You really want to avoid type 2 errors. And therefore, the probability of getting a type 2 error for the AIDS test, beta would be very small. You want this number to be very small. You want beta to be very small. So therefore, the power of a test would be 1 minus a very, very small number. And so it'd be like 0.9999999 or something like that, right? Because beta would probably be 0.000001. Okay? The closer a test is to having a power of 1, the more powerful it is, or the more kind of sensitive it is, the more likely it is, well, the better it is at avoiding type 2 errors is probably the best way to think about it. So we want our tests to be very powerful. So one thing our book talks a little bit about is how do we increase the power of a test? How do you make a test more powerful? Well, there's a couple ways, but let me just mention kind of two of them quickly. One of them is to increase n, increase the sample size. The more people you include in a test, the more likely it is that kind of other results will, the unusual results will kind of get kind of averaged out. And so having a large sample will increase the power of a test. And that kind of intuitively makes sense. If you run an experiment on 1,000 people, you're much more likely to avoid false negatives than if you had just done it on like 5 or 6 people. The other way is a little bit kind of counterintuitive. You want to increase alpha. And kind of the way I think about that is alpha is the probability of a type 1 error. And think about kind of for an AIDS test, type 1 error and type 2 errors kind of, it's kind of like a seesaw. They balance each other out a little bit. So if you're willing to have a lot more type 1 errors, then actually that will decrease the probability of having type 2 errors. Remember, the probability of a type 1 error is alpha, right? So if you're willing to have a lot more type 1 errors, then you increase alpha, that will decrease the probability of a type 2 error, which will then increase the power. Kind of, you have to think about it a little bit like that. But, for an AIDS test, we talked a little bit about how they don't mind having a lot of type 1 errors. That's just a false positive, and it's bad for a day, but you take the test again, and you realize the result is, you get some good news the second time around. And so they're actually willing to have a lot more type 1 errors at the expense of making a really powerful test with very, very few type 2 errors. And there's a few other things that are in the book if you want to read about increasing power, and power is a big topic that we're not going to go into a lot of detail about. But that really wraps up section 11.4 and all of chapter 11. Way to go.